Okay, we're going to finish or touch base on our last concept on slope. And what I want you to be able to identify today is that slope is a rate of change. Rate is really a ratio. Rate of change is how does your y change over how does your x change. That is your rate of change. And what's nice about slope is it is a constant rate of change, meaning once your line starts increasing or decreasing, it is not going to change. It is a constant rate of change. Your y will always change the same, your x will always change the same. So, you need to know that. First example. Myrtle drives the same number of miles to and from work each day, as shown on this beautiful graph below. I want to know, based on the graph, so I'm right here, based on the graph, what is the unit rate of miles driven per day? So what I'm expecting you to know now is I'm going to give you a real-life application of a graph, and you're going to be able to take your knowledge on slope and identify the slope of it. Remember, change in y over change in x. You're going to have to be cautious on scaling, though. Scaling is not always by 1. So you're going to have to check and see, oh, how is it scaled? I better be careful about that. So I want to know what is the unit rate of miles driven per day. So that is just slope. I want to know, how did my y change? How did my x change? And hey, look, y is miles. X is day. Interesting. It is connected to slope. So I'm finding a perfect point. Here's one. I'm finding another perfect point. There's one. And I figure out, how do I get from the left to the right? Keep in mind with scaling. Up 10, 20, 30 over 0.5, 1. I kept in mind my scaling. It is not up 3 over 2, right? I had to be careful about my scaling. I'm going to repeat that. Whoopsies. So it's always change in y over change in x. I find my perfect points. There's one and there's one. Then I want to figure out, how did I get from my left to my right perfect point? How did my y change over how did my x change? So my y went up, look how it's scaled by tens. My y went up 10, 20, 30. And then I'm pausing for a second and just checking my scaling. I see that it goes by 0.5s, doesn't it? 0.51, 0.52, 0.53. So I went over 0.51. So my unit rate is 30 miles per day.
That's slow.
So that is the connection with slope here and unit rate. So they're going to give you a graph and they're going to say, identify the unit rate or the constant rate of change and interpret it. Interpret it means that I write what it really means. What does my slope represent? It's always y over x. My slope represents y, which is miles, over x, which is day. Miles per day. Okay? The last thing that we did, that we're going to do today, is analyze a table. A table is this, it's always change in y over change in x. Remember, slope represents steepness. Steepness means how fast does your height change. Height is y, x is x, also known as time if I'm talking about something like that. So I have x, y. I want to know, how does my y change? From 430 to 860, it looks like I went up 430, right? Let me just make sure it's a constant rate of change. That means that it will do it all the time. So I'm going to go, I am going to go 860 plus 430 sure is 1290. Let me verify one more time that it's still a constant rate of change. So 1290 plus 430 is 1720. So that is my change in y. That's how my y changes. And then my change in x to, yep, that's constant. So then my slope is change in y over change in x for 30 over 2. However, what we're talking about today is making that connection between slope and unit rate. So I want to know how much for 1. So I would say that it is 215 over 1. But you have to word that nice. That's just slope. Like you have to word it nice. So you would say $2.15 per pound. Y over X. Y is money, right? Y is the money over X is the pounds. Just some of you might be like, well, why couldn't I just go 430 is to 2? So how much for 1? It will work here, but it only works for certain instances, and that's direct variation or direct proportional relationships. It won't work always. What will always work is change in y over change in x. So that's why I'm showing you that, because that will never steer you wrong. This will always work, y over x. How does y change over how does x change? And that is your little learning target today.